Right, wait a minute.
I think he's a very lonely man.
Well, we can start with the introduction, anyhow, and then it'll be time.
Right, you are. I'll stand up for that.
Welcome to another one of our winter talks here at the GHC. I'm sure you all know Howard Torode, who's come to talk to us about Project Sigma, our attempt to revolutionise gliders in this country. I think Howard'd be happy to take a few questions at the end, but please don't interrupt him during the
I'll run
talk
through
itself.
this.
Right,
you are. Okay, thanks very much. I'll be delivering this from a seated position because I'm not totally fit at the moment.
Hit the light, someone.
Oh, righto. Goodness me. Right. A couple of sort of church notices, I suppose, before we started. On the flyer for this, it said I was part of the Sigma project. I wasn't actually. The group who mounted the Sigma program were a very tight-knit group. That was part of their problem, I think. And I sat on the fringes of that exercise, and through various evolutions that you'll understand as I work through, subsequently came to fly the damn thing. The other thing I would like you to understand is, yes, I think there's every acceptance from this distance in looking into the past that this thing didn't work. It was a failure. There's really no point in trying to hide that from anybody. That's just the way it goes. But I think you'll see that the trials and tribulations of the program were, and some of the thinking behind the program were flawed, and as a result, yeah, we didn't actually get anywhere with it. So that's, if you like, the disclaimers to start with. Project Sigma started out in the 60s. I've got a couple of slides here. Hang on, let's get this right. No,
Yep.
Left?
Normally just do that.
Yeah? Oh, just here?
No.
No.
I want to go back from it.
How do I go forwards?
Oh, just do that.
Sorry?
There.
Oh, there. I thought I'd press that. Here we are, back to the 60s. Looking at the audience, I don't actually think there's many of you here who don't remember the 60s. But just to refresh your memory and point up a couple of items that might be worth anything. I'm not going to talk about the Beatles or winning the World Cup or the Summer of Love. I spent the Summer of Love at Lasham. There wasn't a lot about, I can tell you. So back in the 60s, good old UK still had an aircraft industry. It hadn't been fully rationalised, so there were a number of various organisations and indeed subsystem makers who were independent organisations, so you could go and campaign with them if you put your mind to it. We also still had Slingsby as a national sailplane designer and manufacturer, so all was fairly good in that, and indeed they had a huge share of the market in UK at that time. We were in the white heat of technology. There was a Minister of Technology and Tony Benn and all that lot, and technology was a driving enthusiasm for advanced projects. Really speaking, if you came up with a good idea, you could usually find somebody to fund it for you. Sponsors and supporters for innovation were readily available. Now, you go to aircraft design, variable geometry was being trialled in a wide number of applications, and there's some aeroplanes there that many of you will be familiar with. F1 Swing Wing, F111 and F14, B1, AFVG. We hadn't even got as far as MRCA, let alone Tornado in those days. And even Concorde. I mean, the exterior of Concorde doesn't change much, but believe me, some of the interior changes hugely as it flies around. So it was a period of optimism and, by current standards, relatively free funding money. Still to come were fuel economics, the sort of things that grind us down these days, risk assessment and very deep project management. If it was a good idea, you went away and did it, and here was some money. Okay, we were also in pretty good shape in gliding. Throughout the 60s, we had very good results in World Championships, except that we never actually won anything. Nick Goodhart, who is a key personality in all this, had of course won the two-seat competition in 1956. But if you look at his results down there right through the piece, Nick was probably the foremost and most consistent glider pilot that we had in the business. And actually on two of those occasions, the world champs at Butz and indeed even at Verschatz, he was actually pretty close to winning the thing. It was just a matter of unfortunate circumstances. At Butz in particular, if only a few other people had flown a bit more and flown another contest day, he would have won it. So Nick was a respected member of the team, and he was actually the driving forces behind Sigma. Now the other piece of information I have for you, which you might find a bit alarming, he said, is this. I plugged through the BGA records, and this is a time plot of every 60 registrations of gliders that occurred in UK. And what you see here is the registrations of the number of foreign gliders in that particular batch. So right through from 1959 to 1965, we had less than 5 foreign gliders registered in UK. We were producing capstans, we were producing swallows, we were producing darts, everything was hunky-dory and the industry was buoyant. But look at this, from 86 onwards, suddenly all these blue lines are K6Es, K8s, K7s, Pirats, you name it. There was a huge swing in 2 years from 5 foreign gliders a year entering the UK. No, not 5 gliders a year, 5 in every 60 gliders in UK every year were foreign. In 1969, 47 out of 60 gliders were foreign. So the industry was really up against it, and it came to recognise that it could no longer operate on the basis of using conventional materials to make, as in wood, to make gliders. This came home most starkly at the World Champs in 1965. I've shown this slide before, but this is a creature called the D36, which was an open class. I think it was 18 or 19 metres, and it was produced by a group of students who subsequently became the chief designers of all 3 major German glider houses. I think you'd agree it wouldn't look out of place on a grid today. It frightened the pants off everybody. It didn't actually win, it came second, because just like Goodhart, he had a bad day as well. But you can see there, this glider that would stand on a grid today, standing next to a few early perpendicular British gliders, like the Dart or the 419, that our guys were valiantly trudging through. So there was a pretty strong indication on our home soil that glass fibre was the coming thing on the continent. And we didn't like it, because it did all sorts of floppy things on you if you weren't careful. We didn't understand composite technology. And even the Germans were struggling with it. So, well, it probably wasn't the sort of sensible thing that the Brits should be putting in. How are we going to cope with this new technology? Britain's answer was metal structures. We had an industry that was used to metal. We understood metal. everybody could work in it, it was understood, it wasn't floppy. All right, it fatigued, but if you were careful with your design, it worked itself out. And in fact, at the same time, the UK industry was producing a whole suite of new metal gliders. Here you see the BG135, which was a single seat club glider, the Slingsby built licensed HP14 from Schroeder in the States, and even our own Deer Beast. So there was a pretty well, a good slice of metal gliders. So all right, we've made the assumption now we're good at metal and we can make a go of it. What can we make in metal that will actually get us the edge? Well, variable geometry is something that requires a certain degree of stiffness. You can't do it in glass fibre, so maybe we'll try variable geometry. How do you vary the geometry of a glider to make it work? Well, there's really only two ways of doing it. Do you do span or do you do chord? Now, I've learned since Sigma time, so this is thinking that's probably post-Sigma, but there's two ways, the two things you can do, and there's a plus and a minus for each one. If you go the way that Sigma went and push out a huge integral flap, the beauty of that is that you can change the wing section. So you can make a section that's suitable for circling flight and a section that's suitable for running flight with the same glider. You get your cake and eat it. What goes wrong, of course, is that when you put the flap out, you decrease the aspect ratio just when you want lots and lots of aspect ratio when you're climbing. Take the span situation, that's fine. You stick the span out when you're climbing and you pull it in again when you're running, but you have to use the same section. So there's a loss on that. And as I was saying to various people earlier, this was pointed out to me subsequently by Fritz Joel, who was a guy who was involved with the BJ series of gliders in South Africa. So you take your money and you take your choice. You can. The one German attempt was to run, as I say, a FS29, I think it's called, to have a variable span glider, and it flew. And by all accounts it sort of worked, but they didn't pick up on it either. So the plan is we're going to have a nice stiff aluminium wing like what the Continentals haven't got, and we're going to use it to morph the wing to give us a cambered high lift wing section while we're climbing and a nice thin fast wing section, albeit with a very slender wing, which we don't actually need, at high speed. You've probably caught the line here that actually in those days most of our modelling was done on a Macready climb glide model, and possibly one of the major failings, well, one of the major things that Sigma didn't understand was the whole business of running slowly in lift and dolphin flying and all that sort of thing. It should actually have worked with Sigma, but we never got the opportunity to demonstrate it. What's I got? So let's have a look at a few timelines. Operation Sigma Limited was an incorporated limited company fully supported by the BGA. I don't know why they chose those words, but I can only assume that they needed to be a limited company to have the proper financial separation, but they needed the affiliation to the BGA in order to encourage sponsors, because a great deal of the money for Sigma was done by sponsorship within the industry, and you'll see various examples of this in the pictures. The undercarriage was provided by Doughty, the brake parachute was provided by Irvin. I think Doughty did a lot of the hydraulics, which I'll come to in a minute. But I don't think many people really quite understood how that demarcation took place, and I think a number of people made the assumption that it was being done with BGA money. It wasn't. It was done by sponsorship on the understanding that people were going to get publicity out of the success of the operation. The chief designer man, his name was John Sellers. He was a very pleasant guy, and I think he was quite competent. I mean, he did the T-53 and one or two other bits and pieces for Slingsby's. He was basically Slingsby's chief designer, and the whole thing was incorporated, as I say, in 1966. Is that a pause?
That's me.
That's you. With the plan, which must have been, even in those days, pretty optimistic of flying it in April '88. Whatever hope went out of that, I've no idea. But nevertheless, studies went ahead on a broad front. Probably a little bit too much aerodynamics and not enough engineering. But nevertheless, here we see fundamentally the layout of the aeroplane, which is up on the wall there. You can look at it afterwards, which was basically an open class 21-metre glider with you can see one side's got the flap out and the other's got the flap in, with one side with the flap out where the increase in area was 35%, so it was a big bite in area. Equally, and you can see the indications on here, it was intended to be a very stiff wing. It had to be, and in fact, even at the stiffness it was one of its Achilles heels in the testing. Why with a stiff wing we necessarily had to have the whole thing so high off the ground, I don't know. It was certainly as high off the ground as an Ash-25, if you will, in this day and age. But again, we had undercarriages and various other bits were supplied by bits of the industry, and I'm not actually sure it was a terribly good idea. If you look at photographs of Sigma's undercarriage, it was massively heavy. And nobody seemed to worry too much about weight, because of course we were talking about a glider that had 35% more area than it needed, if you will. So that's the score. So how did this clever flap work? Here's a picture, and for those of you who are that way inclined, here are some aerodynamic characteristics. Basically you had a wing section that doesn't actually look all that unlike the sort of wing section that we have on ASGs and Ventuses in this day and age, with a very small control surface at the back of a panel which lives inside the wing, and item A at the top there shows you the flap in configuration, the running configuration. You can see that the control surface there is 10%, so it's only half the size of the sort of flap that you would get on an ASG-29 or a Ventus. So it's not going to work terribly well. You don't need it to work terribly well because we're flying so fast and it's such a thin section. What do you then do when you meet a thermal? You shuffle this flap out the back, and you can see that the piece inside the section is motored by means that we will come into later, out onto the wing, and you're now left with a wing that's, as I say, 135% of the size of the region, and the only control surface you've got on it is that little 10% over 1.35 to control it. The whole premise of, I'm sorry, I've missed a trick. The whole premise of the, I won't go back, the whole premise of the exercise was this was a full span flap. There was no aileron bit on the end of the wing or anything. We were going to control this thing entirely by separate controls. And the first time I directly became involved with Sigma was that I ran some wind tunnel trials at Cranfield to evaluate the lateral control facilities, and they were not good, believe me. What we have is that little paddle on the very trailing edge, which can sort of work as an aileron, but we had on top of that a spoiler which came out of the top of the wing when the stick got to a certain position in the cockpit, which spoiled the flow over the inner wing and caused you to roll. It was a deal more powerful than the little aileron, as I will come back to in a little while. I've got further pictures of that here. What I would like to show you on the aerodynamic pictures, the lift curve is on the right, and even those of you who are not used to looking at these things will know that lift is proportional to incidence, and you will see that the flap in curve here is a relatively low lift curve. The flap out curve is a very high lift curve. It achieves lift coefficients of something like 1.7, 1.8, which, believe me, is not the sort of thing you would get on a normal glider section. On the left you see the drag characteristics. I won't go into them except to say that for the flap deflections you'll notice that in the middle there is a reasonable continuity, and in fact if you do the sums you find that the section is designed to have the same min sink both flap in and flap out, and that suggests that maybe you would have been all right footling along a cloud street slowly with the flap in. You wouldn't be any less efficient. You'd be at least as efficient as the other way of doing it. You wouldn't lose anything, and if you hit a good core you could pop the flap out and take advantage of it. So how Sigma would ever have worked in the sort of dolphin, I call it dolphin flying, I know that's an old term, but the sort of follow the energy flying that we do now is totally unproven. I don't know how it would have worked. Let's take the next one. So here we have it. We have a centre wing with flap function in high-speed flight, and indeed spoiler function. Obviously the outer wing you would do that, obviously, and in flap in flight, sorry, what am I saying here? Yeah, outer wing has a lower down, bottom of the picture, lower down you have spoiler and aileron to do roll. In the centre of the wing you have a camber flap, which still works slightly to modify the wing section, but you have a big air brake, well it says air brake, it's a spoiler isn't it, in the centre. So the whole wing is sort of, if you're rolling or manoeuvring laterally, the whole wing is morphing to your command on the stick. The stick was geared so that the first 50% or so of movement was done with aileron, the second 50% was done with aileron fully deflected, and then you put in spoiler. Those of you there are those of you who might well have spotted that, of course, while you're putting aileron in, you're putting in adverse yaw. While you're putting spoiler in, you're putting in the reverse, which they call proverse yaw. So there was an argument that said actually you're going to have to be pretty fly on the rudder pedals as you go from one mode of roll control to the other. Didn't actually work out like that, but I'll come to it. Anyway, research continued apace. We did wind tunnel tests. I'll skip through these fairly quickly, but they give you a bit of the idea of the configuration. That one seems to suggest they've got a wing root problem at whatever condition that is. You can see all that separated flow in the junction there. Not good, but these pictures show you with the flap out. Now, you can now discern from that the sort of difference in incidence between flap out and flap in. Visualize the last 35% of the flap removed and you've got pretty well a 0-0 rig into the wing on the fuselage, but with the flap out you've got something like 6 or 8 degrees. Again, more flow pictures, but they just happen to be there. Again, you'll see pictures like this done, or computations like this done on gliders. I've certainly seen some on the ASG-29, but all I'm really saying is that we went into a fairly broad-based research program to put the thing together. And in fact, I think probably we did a number of things that were less important than actually getting the engineering right. So here's the configuration again. This was a rejig that was done after the... Oh, I missed that on the slide, didn't I? Sorry. But you can see again that somebody's indicating all the various roll control capabilities on the wing, and you can see that the wag has actually deflected the rudder out of the turn in favour of spoilers rather than ailerons. The key to all that was that the roll control was so bad that you never actually noticed whether you were suffering adverse or proverse yaw, and you just got on with it with a bit of rudder. Here's the grand mechanism that shuffles it all out. Now you can see that there isn't a lot of room there for a spar because some of the support structure runs all the way to the leading edge. So there were big holes cut in our metal spar, the sort of holes that you couldn't cut in a glass fibre spar, which enabled this thing to work. The key point that I'd make here is that you'll note on this picture that the trailing edge of the moving surface, the surface that's hatched, is actually thinner than the front edge, which obviously suggests that on the lower surface at the junction you've got a flexible joint, and that flexible joint probably was the Achilles heel of the whole program. So we've got to shuffle all this gobbery in and out. How are we going to do that? Well, we're going to use hydraulics. You can imagine that by the time you've actuated that lot through a hydraulics, and you can see the picture there says hydraulic actuator in the contraction area at the back of the fuselage, there's some pretty fair mechanism going on in there to push it all in and out. And of course there's a hydraulic reservoir. What are you going to do? Do you pump it up? Well, you can't do that because that's stored energy. We can't have stored energy in gliders. That would allow you to put an electric motor and a propeller on the back or something like that. So it can't be carried energy, it has to be created. So it's pumped up by the pilot. How do you do that then? Well, you have a button in the cockpit that you press, which allows you to press both the rudder pedals symmetrically to pump up the accumulator. So the understanding was that the accumulator would be good enough for probably about 8 or 10 flap cycles. So that's 8 or 10 thermals. You probably need it twice a flight, something like that. The other thing, of course, you need to do is to get the undercarriage up. And you can see now the scale of the undercarriage that I've been speaking of. That took hydraulics as well, except that it wasn't off the accumulator. The pilot did it directly by pumping it up himself. You'll be pleased to hear that it fell down by gravity. And it won half a bag and all. So there we go. The next picture is probably not terribly illustrative. This is actually a drawing of Sigma, which was rejigged after the first major mishap in the operation, which was a fire at Slingsby's. Sigma was being designed and built at Slingsby's at the time, and in October '68 there was Graham will remember, there was a mysterious fire at Slingsby's which destroyed quite a lot of stuff. It virtually abandoned Slingsby's ideas of actually marketing a version of the HP14. It virtually killed a lot of their other projects, non-gliding projects that they had had an enormous number of projects. They were stretched an awful long way. About the only thing they continued to persevere with as a Slingsby company was the T53. Why, you might ask. Sigma was badly damaged but was recoverable, but it had to be removed from Slingsby's, because Slingsby's could no longer function. It was one of those things that there was an external project they couldn't continue to support. So what there was of Sigma was reloaded back through sponsors into BAE Engineering at Heathrow, mainly because there were a number of people at the top of BOAC and Heathrow, people like Ken Wilkinson and Bev Shenston, who were glider aficionados, and they saw it as a means of putting some engineering into their apprentice training and what have you. So in '68 there was a huge hiatus, and Slingsby's was taken out of the project. Sellers was retained as chief designer, but the whole thing was set back. The first flight in April '68 had obviously drifted already by then, and there was now no question of it going to the World Champs in Texas in 1970. It might actually have been something like a success in Texas, but I don't know. You'll never know, because that's mystery for you.
Howard, could you hand off the microphone, please?
Oh, I'm sorry. Is that all right? So, Plan B, next World Championships, when's that? Well, it's in Yugoslavia in 1972. Well, we'll go for that then. We've got to rejig the project. What are we going to do? I've learnt, working up for this talk, that Sellers made a strong case for dropping the variable geometry and extending the span to 24 or 25 metres. I'm quite astonished at that. I hadn't actually realised that was done, but it causes me to realise that actually the terms of the aim of the Sigma project were not entirely clear. If you take their prospectus that they sent around industry, I was going to read it, but it's dark. It says something like, to deliver to the chosen pilot for the next World Championships a world-beating glider, blah-de-blah-de-blah. Didn't say anything about variable geometry. But palpably, the management had sold variable geometry to the sponsors in some shape or form, whereby they felt it was absolutely imperative to continue with the variable geometry. So that was the first mutiny, and I'm not even sure that Sellers didn't quit on that, but I can't remember. But anyway, while we're talking through the aircraft, let's look at the cockpit. Actually, it was all surprisingly conventional. It had all sorts of clever bits and pieces that many gliders don't have. I mean, there's an oxygen valve down the bottom here and all the rest of it. The only things that are sort of different are the rudder pedal lock, which you pull back in order to pump up the hydraulics and then put back again to have some semblance of roll control. The undercarriage selector was of course a hydraulic thing, for the apart from the pump up job. There's a camber and flap selector on the right hand side there that you can see, which is a composite flap, big flap in and out, and then a fine tune on the little tiny control surface on the back to add a bit more camber. Other than that, you know, air brakes, canopy jettison, instrument panel, it's all there really. So one has to say from a parachute deploy and jettison, of course, you can see as a slotted gate on the left hand side of the instrument panel. It actually all worked surprisingly uncomplicated. There's probably even more knobs than that in a Kestrel for all I know. But anyway, there you go. So what happened? So I didn't fill in this slide sufficiently last time. We had the fire at Slingsby's, relocated to London Heathrow, subsequent decision that the Marfa World Champs were no longer realistic. We finally came to 12th of September 71. They wheeled it up to us at Cranfield because they wanted a bit of privacy. And the first flights, which I didn't see because I was out on a failed 300 attempt at the time. 12th of September, think about it. But I was there for the second flight, so let's do that. The first flight was actually done by Goodhart, and it was rather brief because he spent most of his time flying around with the pole in one corner because there was a twist, there'd been an inbuilt twist in the wing. And you can see the repair on this picture here on the centre section, where they took it back to BAE, gave it a good old squeeze, did the rivets up again, and it was all right, you'll find. Probably Nick was more frightened than he needed to be, because I suspect all he was doing was holding full aileron, which wasn't a lot anyway. He'd still got the spoiler to deal with, but nevertheless it was a fairly chastening experience. He also had a certain amount of trouble with the rear fuselage fluttering, or fluttering mildly. Of course, a lot of gliders of this time had flutter problems. You've seen the pictures of the SB9 I put up before, but you can see on there already they've now fitted a set of rather unsightly external mass balances just under the Sigma sign on the bottom of the fin. They had RE Farnborough looking after this for them because they didn't actually understand flutter terribly well, and I don't think they ever got rid of those unsightly mass balances, to be brutally honest. He needed quite a lot of mass balance, over 100%, to stop the back end wobbling about too much. Yeah. The third problem you can see just under the knee of the guy on the left wingtip on the right hand picture. A couple of supermarket trolley wheels were installed on the wingtip. The diameter of the wheel was about that much. I'll leave you to work out why. Typically there wasn't enough roll control to hold the wings level on takeoff. The man could run as hard as he liked, but as soon as he let go there was a loud clang. Fortunately you had a steerable tail wheel, so you just sat there with the pole in the right place until the wing came up again. It wasn't a problem, but it was going to have to be something that was sorted out before you were world champs capable, for sure. After these, I don't know how many flights they did, 3 or 4 I think on that day. That's Lorne Welsh flying it there. The thing was transported to Lasham because obviously the cabal that was running the exercise were Lasham people, and it was transferred to Lasham. And here we see, in not particularly good detail, Sigma being rigged outside of the clubhouse. The old clubhouse and the new old clubhouse. I haven't mentioned that it was a 3-piece wing, but you've probably worked that out, and you can imagine the centre section was unconscionably heavy, and we had a special gantry to lower the fuselage onto it. When you consider the probable number of both mechanical and indeed hydraulic connections that needed to be done to put it all together, that was probably a pretty major undertaking. And there's Frank on the front, as I say, probably with a load of new IC students trying to put it together at Lasham. I'm afraid we don't have a lot of pictures of Sigma in flight, but I've put 2 together here in contrast. They're taken in different times, but probably the key one is the one on the right, because it's the only picture I've got, or I've ever seen, of Sigma actually flying with the flap in. And I believe that's taken somewhere around Lasham. It's certainly in the older colour scheme. I don't know why they changed the colour scheme halfway through. But the colour scheme on the right, on the left, is a later colour scheme, I think, if I remember rightly, from when we were flying it at Cranfield, which at least illustrates the size of the area change that you see in the flaps. So, as I say, flaps deployed and reflected, that's the best contrast I can give you of what it looked like in the 2 configurations. So, we get ourselves to about sometime round March, somewhere between July and the end of 72, and I can't remember when, they finally decided we're not going to take it to the Shats either. I should add that during that time, Cranfield had an increasing involvement in Sigma, particularly in that they engaged a good colleague of mine, a guy by the name of Roy Tetlow, who actually did a lot of the detailed stressing and actually made the bloody thing work. I don't think it would have worked without Tetlow, to be quite honest. But having said that, I remember Roy coming into my office at some juncture. It must have been late 71 somewhere. No, it can't have been. But Vashats was 72. It was a very short time scale. But Roy came into my office and said, we're not going to Yugoslavia. And to be blunt, that was the end of it. I think the people who were driving it were probably sufficiently tired. And they just dropped it. And I never really could get my hands round, get my head round the added value of what they were doing. That something must come out of this thing. God, it flies, if nothing else. In retrospect, those of you who follow World Championships will know that it's probably a complete blessing it never went to Vashats, because Vashats was probably the last time that the FAI or whoever it is actually located a World Championships in a totally unsuitable location. The weather was awful. There were thunderstorms in mountains. I read that the two of the Swiss team actually contemplated bailing out of perfectly serviceable gliders at one stage because they were so frightened about the terrain and the atmospherics. You've seen Sigma's gantry for rigging it. It would have sunk without trace, let alone fly. And in all honesty, Nick flew an HP-14, which was a far from sorted glider in Vashats, and I think came fourth, which is actually quite staggering. But as a competition glider, Sigma died overnight. As a technology demonstrator, it was still valid and it flew. And basically the management team of Sigma dropped it overnight and basically said, how can we sort of carry this on? Well, even in 72, money was reasonably loose and a certain amount of MOD money was found to fund it where I was already doing research at Cranfield. So it came to Cranfield. And we flew it at Cranfield doing performance testing on it. And subsequently some aerodynamic research to try and understand what was really going on with the flap and its junction. But I haven't actually spoken anything about flying Sigma, which I don't doubt you'll like to hear about, and I'm one of the few people left who can actually remember. But before I talk about that, there's Sigma at Cranfield. Still got the mass balances, still got the wheels on the wingtip, being hooked on. Flying it with the flap out was relatively conventional. It had lousy roll control and the yaw coordination was a bit quaint. Sorry. But apart from that, it was fair enough. It had Frank Irving's favourite all-flying tail on it, which seemed to me to be relatively powerful. But it was relatively light, because all-flying tails generally are. So in pitch, it was not unlike the similar weight modern high-performance two-seater, except that with the flap out, it didn't actually go much faster than about 60 or 65. You sat there with a good view of your feet, but I should add, the flying I did in it was not soaring flight, it was flight testing. So most of my time was spent flying steady speeds, measuring things. Usually early in the morning before the cumulus had got up. I never flew it in a thermal. But from a handling point of view, it wasn't half bad if you accept modern two-seat glider performance of a rather larger span. It was about the same weight as well, it's about 1,500 pounds. All the pumping up and down and undercarriage and all that was all right. You only had to do the undercarriage once per flight. Sadly, the friction in the flap system was such that you probably had to pump the accumulator up every 2 or 3 flap cycles rather than the 8 or 10 that they imagined. But the big shock came when you pulled the flap in. Now, you've seen that the incidence line on the wing, flap in and flap out, difference is about 8 degrees. And that, of course, manifests itself immediately in flight path angle when you whip the flap up. So when you whip the flap up, it's well, as you'd expect, because you're actually lifting the flap and you want to go faster. The difficulty is that once you get to about 70 knots, the skirts around the flap start to buzz. And in the early days, apparently it was pretty near threshold of pain in terms of having the flap buzz. All that I ever heard was a buzzing noise and the glider starts to fall out of the sky. And within the context of the flying that we did in it, we never actually solved that problem. That problem was never solved. And in fact, notwithstanding the rear fuselage flutter and the lateral control on takeoff and all the rest of the shortcomings, a lot more effort should have been put into sorting that gap problem out. It was the key to the whole aeroplane and we never got near it. But anyway, you see in that being hooked on at Cranfield, Peter Bisgood's doing the flying. That's me with the walkie-talkie signing up to hook it up. And just to prove that I flew it, there you go.
Outrageous sideboards.
Thank you. Well, it was the 70s by then, you know.
That's right. A lot of drag in those.
Yeah. You can see in there that the constraint for the pilot's a bit odd. And actually, I gathered that during the Lasham trials, there was a lot of goings on. Irving's had come up with this system whereby you were actually strapped in laterally across your torso. But of course, as soon as you started pumping up the rudder pedals, the first thing you did was stick your head through the canopy. So we actually had, eventually we had constraints down this way as well. But I don't think there was any constraint forwards. And I should think Tony Siegel would have had a heart attack if he'd seen the thing. But there you go. Just for the sake of the debate, those cans on the front are modified sensors for airspeed and altitude, and they were the sensors that were doing the performance testing. I don't think there's anything else much to say, except you'll see that the head restraint is relatively rudimentary, but does at least stop you pushing yourself through the canopy. The whole cockpit, in spite of all the care taken in the ergonomics, was one of the most uncomfortable cockpits I've sat in. Notwithstanding the supine position, you were sort of craned backwards rather, and you didn't get the opportunity of having a sort of upward curvature to your spine rather than a backwards curvature to your spine. So it was all a bit unpleasant in that respect. I didn't speak about putting the flaps back out again. That was the whole transition process. Once you got used to it, was actually pretty sensible. You pull yourself back to 65 odd knots or so. I think the fastest we flew it was about 90 or 100, by which time, you know, everything was clattering so much it really wasn't worth it. But you selected flap in, there was a loud hissing noise and a clunk, and out came the flap, and the whole thing just sort of went, Ah. And up came the nose, and you know, when you got it right, because you knew what it was like before, you stopped it, and that was it. The whole transition, which worried everybody considerably in a handling point of view, was actually totally kid stuff, apart from keeping the flap shrouds under control. So you all want to know what it performed like. There's a Polar. This was drawn by Cranfield after I left, and it's as good a understanding as I can have of how things were. They've done a good job in that they've shown you the dotted line, which is what it was supposed to be, compared with what we actually measured. And those are actually, you know, measured performance. It's not somebody's wet finger in the air, it's for real. I don't know that I believe about the shroud buzz only cutting in at 90. Certainly when I flew it, it was somewhat earlier than that. But shroud buzz really was, you know, the death knell. There was no point in proceeding along there. And you'll see that basically we got about 1 in 42 out of it with the flap up, which is not good for what we were after. Obviously they were looking for 1 in 50. The other point that I would make is that in both flap in and flap out performance, we actually got the same min sync, which was something I pointed out on the aerodynamic curves that we were aiming for. So anyway, that was what Cranfield got out of it. What we tried to do after the performance test was to look at the wake of the wing and see what the wake deficit was and to see what the actual drag component was due to the section and the blowing flap, rather than anything else that might have been going on around the fuselage or anywhere else. And I was astonished to find, because I'd never seen it before, this picture, which I'll try and explain to you, which is a wake deficit diagram. Basically you're looking at pitot pressure in a region just behind the wing trailing edge, so that outside of the wake you see full dynamic pressure at this point, 2.4 inches of water, but the wing itself is producing a wake deficit in that big bucket there, which essentially the area within that bucket is the amount of drag that's being produced by that particular slice of wing. And the idea was to do these trials with various patches on the shroud to see if we could make an improvement on that deficit well in dynamic pressure in the wake of the wing. But I've only ever seen that one picture. As I say, I'd left Cranfield by that time, and furthermore at that time Cranfield had actually managed to break the aeroplane. Sad situation. One of my colleagues, one of the TPs at Lasham, who did have, not Lasham, Cranfield, who had gliding. Can I go backwards? This guy was a glider pilot and tug pilot, and he was on the staff at Cranfield. He didn't actually understand a lot about performance gliding, but because it was lodged with Cranfield, he was to fly it. Took off one day. I was at work in London at the time. The phone rang. And halfway through the ground roll, the brake parachute came out. Now, I hadn't understood, to be honest, at that time, that the original team had had a lot of trouble with brake parachute reliability. And there may be people here who actually saw Sigma arrive here in various odd arrangements because of failures in the brake parachute. The brake parachute was a great deal more powerful than the spoilers, which made it pretty well useless, to be honest, because you had to commit yourself either to a spoiler approach flat or a brake parachute approach steep, and if either didn't work you couldn't do the other. So it wasn't very helpful, but having the bloody thing, it was a big chute because it had been designed by Irvins. probably bigger than you needed, but the net result, if you look at the picture on the wall, or you may have seen some of the pictures, oh, you can see here, the release unit is actually roughly at the level of the top of the wheel. Now, we know in this day and age that, you know, that's a recipe for a tug upset. It was a tug upset going somewhere to happen, basically. It was going to happen to somebody sooner or later, and sadly it happened to poor old Harve. So you can imagine, with a really low rope angle and a really high brake parachute angle and a really efficient curved plate wing section, the bloody thing just shot into the air, and he ran out of pitch control, and the whole thing thudded back onto the runway. It broke the underfin, it broke the undercarriage, it broke poor old Harvey fairly badly, and I'm told that notwithstanding all the stiffness constraints, both wingtips touched the ground. It's probably saved you a bit, but it was a bad accident. It was repaired under insurance, but at that point the impetus had really gone out of it, and even the mod contract came to an end. The variable geometry glider was, oh, let me just skip through this. Yeah, the variable geometry glider wasn't really working. There was nobody at Cranfield to pull it all together. Even the guy who replaced me quit and went to work in Australia. It fell moribund for a year or so when a visiting professor turned up from the University of Alberta. His name was David Marsden. I never met him because, in fact, I left to go to test pilot school a year after that. But he turned out to be a fairly practical engineer guy, and effectively it was agreed between the powers that be that we give it to him, and he shipped it off to Canada. I'm afraid research that I've tried on the internet, I know that he took the area changing flaps out. I don't know whether he fitted part span Fowlers or conventional flaps. I don't know what. I mean, by the time you pulled the hydraulics out, you'll have saved yourself an awful lot of weight. So probably at 29 metres you'd make a go of it. I'm inclined to think he used Fowlers. That is to say, separate flaps with a leakage between them and the wing, like a Blahnik, for example, which are not actually very favoured in gliding terms because they incur a certain drag penalty. How am I doing time-wise? We've only got 5 minutes. All right, I'm nearly there. So that was Sigma. I'm afraid I can't tell you what happened to it in the States. I believe it won competitions. But it was re-engineered and it wasn't VG anymore, so I'm sorry, it isn't part of this lecture. You'll have to get hold of Marsden to tell you about that. What I do want to talk about, though, is other flap designs. Those of you who follow World Champs will be aware that in Châteauroux in 1978, Reichmann, very well known as you know, glider pilot, flew a modified AS-20, modified by Ackerfleet Braunschweig, with a flap design very similar to Sigma, except for two key points. One, as you'll see on the bottom left, it wasn't full span, and the other was that the moving part of the flap is constant thickness, so it didn't need a shroud. And Reichmann won with that. But it was never followed up, and Reichmann made a couple of remarks that got me thinking, over and above the business about variable span versus variable chord, why we actually have variable geometry gliders. Because Reichmann said the flap only really worked in tight thermals. I could outclimb people in tight thermals, but the min sync with the flap out was greater than the flap in. So in fact, in conventional thermals, he was fighting with it. Well, those of you who've read about world champs know that Reichmann flew and won more world champs than most people, and was also noted for being able to win a world champs in spite of his glider. And he literally said that, I won that world champs in spite of the SB11. And I thought a bit about the min sync thing. And then I thought about what we do today, because of course, in the meantime, there were other people in Germany who were making enormous conventional gliders like the SB10, which is probably a forerunner of the Ash 29 for all I know, but it was 30 metres of span, guys, and they were flying that around and winning competitions with that. So we didn't pursue variable geometry because ours didn't work. The Germans made one work. In fact, I could go into pictures of several other VG concepts like the FS29 with variable span, and you can make the basic conclusion that, well, the complication just wasn't worth it, quite honestly. But I've got another thought, and I've only had this in the last week or so, and I'd value a few thoughts on it. What VG actually is the perfectionist's water ballast. You pull the flap out, you pull the flap in, you jettison the water, then you put it back in again. So you can fly around the course, taking the water ballast out and putting it back in again. Now, that's all very fine if you really want to do that, but people who win competitions win it by keeping the water ballast all the way round. So why bother to push it in and out? So that's my own water ballast argument, if you will. It would be fine if you were still doing free distance tasks and at the end of the day you wanted to foozle about in weak lift and fiddle around. It may even be useful to one of you long distance runner guys here at Lasham who want to fly from sun up to sundown, but it actually isn't going to do you any good in competitions because you've got the water ballast. You can fly with the water ballast in, and you pick the best thermals because you're a winner, not a loser. So if you like, I think I'd almost describe variable geometry as a loser's charter, if you see what I mean. It may not be a true argument in its own right, but coupled with the complexity, I think that's why we don't do it anymore. And that's it, folks. Thank you very much.
Thank you very much, Howard, for a fascinating talk.
Good.
Have a little time for a few
Yeah.
Perhaps I can just to start it off. I mean, was there ever a lesson learned report that came out of it, or did it?
No, bluntly, without mentioning names, the cabal that mounted the exercise walked away. They didn't want to know. And the work that was done at Cranfield was relatively academic, and in all honesty, we were never, at Cranfield, we could make measurements and we could understand the problem, but we didn't have the facility to fix it. You'd have had to take it back to somebody else as yet undefined. I mean, it's fair to say, of course, that during this time, George Burton had left the Sigma organisation and was now managing director of Slingsby's and was putting together the deal with the Kestrel and the Vega. You might have got George to climb back in it, but I think George was probably sufficiently of a businessman he wouldn't have wanted to know.
Okay, thank you. Some other questions?
Yeah.
Were the flaps in or out, or could you be any position?
No, bang, in or out. Tailor limit.
No halfway house.
No. It was a whole concept that was literally endowed to Sigma and anybody else who wanted it by Bertman from Stuttgart, the wing section designer. that picture I showed you earlier of the section design were his tunnel tests. That was available in open literature. Anybody could make the VG glider, but it had to be 35%, which is an awful lot, remember, and bang bang, and that was it. Now I think you could make bang bang work. You take the SB11 and Sigma. If you'd use the SB11 approach compromise to solve the shroud problem without actually compromising the wing section as the SB11 probably had done to the detriment of the flap out min sink, then maybe you'd have a workable proposition. But the whole insistence of doing that on a 21 metre open class full span vehicle was frankly over optimistic.
Okay. That's fine.
What sort of sections did it have? And did you ever do any testing with it fully sealed in both configurations?
No, we didn't. When you say what sections did it have, I've shown you the pictures. They were a specialist Workman. Workman actually set about designing a pair of aerofoils with a retractable flap that would be optimum in both conditions. I'll try and clatter back.
It should have worked.
It should have worked, yeah. I mean, there's your key picture. As I mentioned in the lecture, the flap in wing section is probably a little bit more symmetric than you'd see on a 29 or a Ventus 2. But of course the Ventus 2 or the 29 has a 17% flap rather than a 10% flap. So the flaps are going to be that much more powerful. And of course they're light enough to make that work, depending on how much water Roy's shoveled in that day.
When you look at the polars, it doesn't seem to reduce the circling speed as much you'd expect with that much extra wing area.
Can you work that out from a set of polars? You need to do the wing loadings and all that.
Because it was like sort of, best glide was like 60 knots or so, and the circling speed was sort of around about 40, wasn't it?
Yeah.
It's quite a.
I think
More of a game.
the key.
Between the two.
I can lay this on you, Roy. The rest of the organiser. I mean, by the time you've put the Reynolds number dependency into these drag curves, what you get in the way of a meet-up between flap in and flap out probably has reasonable continuity to it. And that was certainly the intention. As I say, people were beginning to understand, even in the late 60s, that miraculously clever pilots could beat Macready, and they could beat it by a whole slice that was unexplained. And the unexplained slice was flying slowly in and straight in ascending air. Don't need to tell you that. So there was a recognition that we needed to keep a continuity between flap in and flap out. But to be brutally honest, all the performance optimizations, the sort of thing that Shemps do every week on a Monte Carlo basis, was done basically on an Algol program on a Macready climb glide optimization basis. You can't hide that. Do you have a? I turn to Roy because I know he's a no. He thinks about these things. Do you have a view on my sort of water ballast analogy?
I really thought about it in those terms, really.
I mean, basically with Sigma, you didn't have any water ballast because there wasn't any room because the wings were full of actuator. But you're already flying a glider full of water ballast. Yeah. It's probably why the wingtips fell on the runway every time I flew it.
You said it was 1,500 pounds, so sort of 700 kilos, something like that.
Yeah, yeah. It flap it.
One fully ballasted.
Oh yeah, it was a. I haven't got the numbers, but it was a meaty wing loading. It was £10 a square foot, whatever that is in metric, 30 odd. So as I say, if you like, the extending wing area can be thought of just as a change of wing loading, just like putting ballast in and out.
Yeah.
And as I say, the guy who wins by getting the best thermal when it doesn't matter whether you've got the flap in or out.
Yeah.
So in a way, it's probably a victim of modern task setting as anything else.
Well, thank you, Howard.
Righto, folks, thank you very much.
Cool, thank you. Thank you.
Well, I hope you enjoyed it. You're good.
Just to remind you, next month, third Sunday of the month, we're going to have our final talk of the season. Gary's going to be talking about renovating the Spallinger, and there's also going to be a talk about glues and what to do with
Oh
them.
dear.
Robin Birch.
So, is he here?
Who?
Gary.
Yes, yeah.
So by next month he's going to want to have flown it, is he?
No, he's going to be talking about putting it back together and not flying it.
Oh, righto.
You should aim for it anyway.
I'm under some pressure in my role in the BGA to grant him a permit to fly at the moment on the Spallinger.
Anyhow,
But we've survived the TG3, so there's hope for us yet.
good. Well, thank you very much.
Can I